Hey, what's up YouTube? My name is Mason, and this will be the first video of my series on how I'm going to be converting a gas car into electric. This video will be for those of you who are interested in building or even just learning about electric cars. But I'm no expert myself, so I'll be learning just as much as you guys. But before I begin, I'd like to thank this video's sponsor, batteryhookup.com. Battery Hookup is a company based in Bensalem, Pennsylvania that provides low-cost energy storage solutions. The products are genuine and tested. For whatever project, if you need batteries, this site is for you. If you're interested, check them out with the link in the description below. Okay, so in this video, I'll be building a modular battery pack. I'll be using it in off-grid storage and also small personal vehicles, but for this project, it will be used to power this motor, which will be used in the conversion. With that being said, let's move on to the battery. Okay, so before we get into the build, I'd like to introduce this project and why I'm doing it. I'm converting a 1995 Geo Tracker into an electric drive using largely recycled materials or reused from other applications. For example, the electric motor is from a forklift and the batteries are from, like I said before, modems. One of the reasons that I'm doing this is that I want to see how far we can push the envelope and how we use our resources that we'd otherwise throw away and give them a second life. The battery that I'm building is going to be single-handedly the most crucial part of this build because without a battery, you cannot have an electric car. One of the benefits of using lithium ion, which I'm going with, over lead acid is that lead acid batteries have something called a lead foot tax. This refers to the fact that lead acid batteries have very low energy density. So as I mentioned before, because lithium ion batteries have a much higher energy density, in order to achieve the same capacity, you only have to use a fraction of the weight than if you use lead acid batteries. Another benefit of lithium ion batteries is that they charge/discharge much faster than lead acid. So I designed this model a while ago just to give a general direction of where I'm gonna go towards the build. I just got some general dimensions and materials that I wanted to use. Things and components may change along the way for this plan, but this is a good general direction to follow. So with all that in mind, let me show you my model. So here's the 3D model of my battery pack. I'm just gonna keep it simple and short and go over the general components that make this up. So the blue cylinders you see are the battery cells that we received from batteryhookup.com. There's 480 in total because there's 24 in series and 20 in parallel. That will net us a total nominal voltage of 88.8 volts, a capacity of 27 amp hours, so that'll be roughly 2.4 kilowatt hours. The frame is going to be made from 2525 profile aluminum extrusions. The reasons I chose this is because A, they're very lightweight, and B, they're extremely modular. So if I want to attach on any components here, say if I want to go solar, I could attach on a inverter or a charge controller, and it would, or if I want to attach several of these battery packs on top of each other or on the side, I could do so using these frames. This silver panel you see over here is going to be the BMS. This small black box is going to be the fuse, and this large black box over here is going to be the charger, but that could change later on. These panels are currently for display purposes. They're going to be made out of acrylic. They will change later on once they're actually in use on the field. I'll probably change them over to polycarbonate or perhaps some sort of lightweight metal like aluminum or just a general polymer. The bottom panel over here, if you look over here, if I can rotate it around, is going to be made from pressure treated 1/2-inch plywood that will be coated. And the reason I chose that is because wood is non-conductive, and that will play into this later on when I show you. So if you look over here, this is the battery management system we're going to be using. It comes from AliExpress. It's obviously not the best on the market. We could go with the Orion, but you know, the Orion itself, just buying that is larger than the budget of this whole vehicle. I just want to get this vehicle moving and just use some recycled materials, not necessarily use the best materials. We'll see how that plays out later on. So these are the battery cells that we're using. They're Samsung INR 18650 15M cells. Each of them have a nominal capacity of 1500 milliamp hours. However, these are used, so they will be roughly 10% or less discharged. So that's how I took into account the capacity once I calculated for the nominal capacity over here. This will comprise the main cost of the project, but I really do like these cells because, well, I'll show you the specs over here. The maximum discharge of each cell is 23 amps. So with 20 in parallel, that's a theoretical maximum discharge of 460 amps. Though realistically, we're not going to be seeing that. The motor will pull maximum perhaps 250 to 300 amps. The charge rate is a little bit slow. It's at 4 amps, but that'll be all right for this project. Let's go on to the build itself. All right, so we're gonna go ahead and make the bus bars for the what's called the parallel connections, to which we're going to solder on the fusing wire. So I'm just gonna show you what I ended up using. So I ended up using a 4-gauge grounding wire that I bought from my local Lowe's. If you can see the package over here, it was pretty cheap. They were like 20 bucks per package. I bought 2 and I had a lot left over, right? And so obviously, you know, I have 24 cells in series, so I need 24 bars in total. As you can see, here I have a bar. Now, obviously, a problem with the wire is that it is curved. So the trick to get them straight is that you mount them in something like a vise, and you put the other end in a drill chuck, and then you just go ahead and spin it until it's straight. And then these over here, there are 22 of these. So this would be the last 2. The very last 2, right? The rest of them were 40 centimeters because the length of the parallel connections is 40 centimeters. The last 2 are going to be 43 centimeters. And the reason for that, the extra 3 centimeters is that at the ends of the pack, I'm going to want the, I'm going to mount these little 4-gauge lugs at the end. In order to like get them to be the right angle, I need to turn that little angle. So that's why I'm doing the extra 3 centimeters. And then over here, this is how I measured it. And then I'm using a bolt cutter to cut these. And then after I'm done making all these, what I'm going to do is I'm just going to take some steel wool, just scrub down the outside, and then before I actually solder on the tinned copper wire, like the fusing wire, I'm just going to take a little bit of flux, heat it up, and make sure the surface is nice and clean. So let's just get on with it. By the way, my tip to you, first off, when you're doing so many in a row, it's a little hard on your drill, so you may take a break between the wires, let it cool down. Otherwise, the thermal, I mean, if it does have a thermal brake circuit, it's just going to trip that and shut off the drill. Another thing is I recommend you get use a drill with a keyed connection, because you need to clamp this on pretty tight in the a keyed chuck. You need to clamp this pretty tight in the chuck, and after doing 11 of them, it's really hard in your hands, taking off skin, and so maybe wear gloves or something like that. So we're just gonna bring it on over here. I'm gonna trim off like the first few centimeters because it has the drill chuck marks. And then I'm going to use a Sharpie and measure out 43 centimeters. Let's see. That's about 43 right there. I'm going to cut it at that mark. And we're going to measure out another 43 centimeters. That's about right there. We should have a little bit left over. As you can see, there's a lot of cutoffs over here. But so there you go. What I'm gonna do next is I'm gonna mount these in this vise, and I'm just gonna bend over the little 3 centimeters. I'm gonna do that off camera, and then the next part of the video is going to be making the jig to solder on the fusing wire. And so stay tuned for that. All right, so now we're at the point of we already straighten out these copper bus bars. I cleaned them off camera. I took a Scotch-Brite pad and I just sanded these down. I took some flux, heated it up, and made sure everything was clean, cleaned it off with alcohol and whatnot. So these are nice and bare. So this is the base bar over here, right? So at this point now we need to solder on the fuse wires. In a few moments I'm going to show you how I actually soldered them on, but here's the plan, right? I have 24 in series, and there's going to be one bus bar for each series parallel connection, right? So if you look closer over here, you see that each of the bus bars, right, are going to have a little 26 gauge fusing wires made out of tinned copper, right? And they're rated to blow at roughly 20.63 amps. The maximum current rating for these cells is 23 amps, so that's pretty comfortable. I am fusing these for the event of a dead short, not really for what I actually use it for. So at either end, there's going to be these bus bars with a little angle with it. These are going to contain the lugs, right, for the positive and negative. And my general direction that I'm heading in is try to make the current flow this way. Okay, so I don't want both negative and positive like right next to each other, like over here. I want them opposite and diagonally of each other. So that's the overall plan. I'm going to show you how I solder these, and then I'm going to solder the fuse wires to the cells themselves, which only take a little bit of heat. Not optimal, but it is what it is. Here's the jig that I made for getting these fuses onto the bus bars. I got this idea from another YouTuber. I don't recall his name, but I think it's a really efficient idea. So basically, you find out the length of it. So it's like 40 inches, right? 40 centimeters. And you just make marks on either end and make a straight line, right? And then these three I just used trim nails. These 3 trim nails kind of keep it from moving this way and also from moving this way. And I have 2 more nails over here that just line it up in a straight line. And all I did was I measured in, if I remember correctly, it was like 19.2 millimeters. Well, first off, it's only about 10 millimeters from the ends, right? But then the rest are separated by roughly 19.2 millimeters. I made a line, and then on one side, I have the nails right up against the bus bar. Only reason being is that I only am fusing on one side, right? And then the other side is, if I remember correctly, it was roughly 2 centimeters. And if you remember on just a few moments ago when I was explaining the fuses, it may seem that those fuses are hair long. Well, that's because it gives it a little bit of slack. That way, in case of vibrations, those fuses don't just snap off. And so here's the 26 AWG tinned copper wire. I'm using rosin core solder. This is with lead. You know, you can use lead free, but it's really hard to solder with it. I'm using this soldering iron over here. It's turned to max. Because you have such a large, you know, conductor over here, it just, you know, dissipates a lot of heat. So you gotta make sure you use a, you know, a more powerful setting or a more powerful soldering iron. So, you know, of course, I got some flux here. I got all the soldering tools and whatnot. I'm gonna show you how I wrap this. So at this point, you have a completed bus bar with fuses. See? It's kind of nice, eh? And so I've already made another one, so I guess I have 22 more to go. So I'll see you on the flip side when I get finished with that. All right, guys, we're back here with the battery pack fully assembled, right? And so what I did off camera was, first off, I finished the 24 bus bars that go on the top side. Took forever to make, but you know, it's well worth it for the protection. Also, when I assembled this, I took off the top holders, and then I realized they were really hard to disassemble. So I shaved off the mating nubs to where it had one on each side. Just made life a lot easier in case I need to take it. I need to take it apart again. And then also I noticed that this pack flexed a lot, right? And so first I was thinking that I was gonna take some zip ties and just you know, zip tie the two ends together, but that honestly was not a great solution. So what I ended up doing was a 1 per 4x5 block. I just drilled you know, a hole through both sides and connected them with machine screws and nut. And so now the pack honestly like does not flex at all. So that's good. So the plan, like we mentioned earlier, was that this is the bottom side, by the way, right? So the bottom side is gonna get these nickel strips that go across the parallel groups, right? So there's gonna be 24 of them. And then at either end, there's gonna be these small nickel strips that connect the, you know, the groups in series. And so on the top side, you get the same, except for you don't have these long nickel strips. You just have these, you know, series nickel strips. And then for the parallel, we have these bus bars for protection. And so, you know, since this has a lower resistivity than the nickel strips, the current should favor this, and thus it should blow that first. And what we're gonna do is we're gonna attach these in parallel. Oh, sorry, we're gonna attach these with hot glue, just like, for example, like so, right? And then we're just gonna put hot glue, maybe 1 per 4x5 block. That way we can still remove it for maintenance, and if we need to remove a cell. And then I already did a test over here. So in order to get these nickel strips on here and also the fusing wire, is I'm gonna use a spot welder. Soldering isn't such a great idea. We don't want prolonged heat on these batteries, especially, you know, them being used. So we're gonna use this. You know, I played around with the settings, and I gotta say, this Sunco 709A, it's not that strong. I tweaked with everything. You know, even like, for example, the electrode distance, it wasn't great, but I got it to work. I found out personally that on my batteries, now results may vary for you, is that I needed 4, so each time it welds, it's like 2 little spots, right? I needed 4 per battery. And so, you know, I'm just gonna go across, get all these done. First, I'm gonna get the parallel groups done, and then get the series done. So this will be the most negative side of the battery. This will be the most positive side. This is the underside right here. I'm gonna have to turn it because the leads on the spot welder aren't that long. So I'm gonna, yeah, like I said, I'm gonna have to turn it around and just to get to the other side. I also still need to attach the lugs via crimping and a little bit of soldering here. This will lead to the 2-gauge welding cable. That way we can, you know, have the power transmitted. Other than that, let's get started. Okay, so now that we're done with the parallel groups for the underside, now we need to do the series. And the way it's going to work is that since it's the most negative side over here, we're going to start the strips at the end, like so. See, it's got another one. And then on this side, we're going to, since it's the most positive side, and this is the underside, we're going to start the strips from like just one from the end. So I'm just going to show you how I'm going to do just this one row, and like the parallel packs, I'm going to you know, restart the video once I'm almost done with this. So let's go on ahead. So I'm just going to place it like so. Just going to drop a spot weld. There we go. There's 1, there's 2, 3, 4. And that should be nice and strong. All right, and then on this end, I'm gonna do the same thing. When you redo that, you make sure to apply a good amount of pressure. Nice and strong. And so we're gonna restart the video when I get to the end.